Okay, so since Nehal and everyone's here now, let's start. Today we are going to be learning a lot of different concepts, so bear with me. I'll just share my screen. So everyone, let me know if my screen is visible, then we can begin. Visible? Okay, great. So first thing that we'll learn about today is friend functions. Okay, so what are friend functions? Friend functions are non-member functions which can access the private members of a class. So that means that you will declare a friend function not within the class scope, but still it will be able to access the private members of the class. To declare a friend function, its prototype should be included within the class, preceding it with the keyword friend. Okay, so now it can be a function, it can be a function template, a member function, a class or a class template, in which case the entire class and all of its members are friends. It can be any kind. So a friend can be any of those things. Okay. Now to declare a function as a friend of a class, precede the function prototype in the class definition with the word friend as follows. We'll see that in the program. Just give me a second. I'll show you the program for friend. Okay. So now let's see the program. We have our header file using namespace std, a class box with a private variable width and public friend void print width box. So we are sending an object of the box class into the friend function, and it is just the prototype that's declared here. We have not included the definition. And then we have a proper class function called void set width, and we are passing an argument inside it. Now the member function definition will be the way you all know: return type, class name, scope resolution operator, name of the function, and the argument list. And then we are saying that whatever we are sending here, the WID width, shall be assigned to our class variable width. Okay. Now note, print width is not a member function of any class. See how we are declaring it? We are declaring it without the whole return type and scope resolution operator and class name and all that. We are just declaring it the way we would normally say a function is like. Okay. So we have void print width, and we are passing an object of the box class in it. Now because print width is a friend of box, it can directly access any member of this class. Now we are going to print the width of the box using the cout statement, and we are going to say box.width. We are using the normal way to access any data member of the class, which is object name dot and then the variable name and ended. Now the main function will be as follows: int main, creating an object, box.setWidth, and we are passing 10. So this 10 will be assigned to our class variable width. And then using the friend function to print the width, we are saying print width, not box.print width, print width directly, because it does not belong to any class. Print width, and we are sending box, that is the object box of class box, inside as an argument, because that's what it expects here, right? This is how a friend function works. I'll just execute it to show you the output. See, width of the box is 10. So this is how you can use a friend function. As you can see, we included its prototype with friend added to it inside the class public definition. We have not written it as a part of the class's scope. We have written it as we would write a normal function. And even in the main, when we are calling it the way we would call a normal function without using the class object to access it. So everybody just let me know if they have understood how a friend function works. and then we'll move ahead. Is the program and how you use it clear to all of you? Please explain friend again. What do you want me to explain, Maitri? Unmute and tell me what exactly do you want me to explain. Friend is a very broad term.
Means what it is doing exactly.
The friend keyword.
Yes.
So the friend keyword tells the class that it is a friend of the class. It is not going to affect the whole need for encapsulation thing. And it is going to say that since this function is a friend of the class, so it can be used for the class and can be used to access the data members of the class, but it is not within the class scope. So you can use it for any other class also. So you can have multiple classes with the same function written, and it will be defined only once, but since it is declared as a friend of all those classes will be able to use it, and that function will be able to access everything of those classes. So that way you don't have to write multiple functions. So suppose this print where thing is required for many things. Maybe you have not just print width, actually that's very limited, but that's just for a box, but it can be for anything. So then you won't have to write that particular function each time for every single class. You will be able to use the same function by defining it as a friend of any class that you want to use. Okay, so is that clear? Does anybody else have any doubt regarding the whole friend function thing? Can you send the code? Of course, this entire folder, I'll be sending it on our group once we finish the whole CPP thing. And I'll send the presentation also where I will write every place where every single code name has been used. So you can, go through the presentation and refer the code simultaneously. As for today, if you want me to send the code, I will send it today also. So that also I'll do. Is any other question remaining, or can we move ahead? Let me know. No questions here. Okay, great. So we can move ahead. So let's go back to our PPT. And here are some important points about friend functions. Friend should be used only for a limited purpose. Too many functions or external classes which are declared as friends of a class with protected or private data lessens the value of encapsulation of separate classes. So if you just keep using friend functions all over the place, then that entire data binding, encapsulation, security of data is wasted. So you should use it for limited purpose only to make things easier, but not so that it threatens our entire data security thing. Okay. Friendship is not mutual. If class A is a friend of B, then B doesn't automatically become a friend of A. So when you see friend classes, you will understand it a bit more. And friendship is not inherited. So each time you actually want to use the friend function, you have to put the prototype there, just because you are using inheritance, and if there is a friend function used in a particular class, that does not mean that the other class which is inheriting stuff from the first class will get the usage of the friend function. Over there, you also have to write the prototype of the friend function in order to be able to use it. Okay, so these are just a few rules. Now let's go on to encapsulation. I know we have talked a lot about this, but just a few things that I wanted to explain. Okay, so encapsulation. What does this mean? It means that the sensitive data is hidden from the user. So for this, what do? We declare class variables or attributes as private so that they cannot be accessed from outside the class. And if you want others to read or modify the value of a private member, you can provide public get and set methods. So what are these get and set methods? We can use them to access private members of the class. Let's see the program to make it a bit more easier to understand. So I have my header file using namespace std. I have a class employee. The private member of the class is a salary, which is of data type int. The public members are void set salary and int get salary. Okay. So set salary will take this argument from the main function or wherever you create the object of the class, and salary is equal to s. So this will assign this variable, that is the private attribute of the class, equal to the value that we are passing. So this way, since it is a public function, we'll be able to access it, and we will be able to alter the values of the private members of the class using this function. So this is set salary. Similarly, we have a get method which returns salary. So then we get the value of the salary, and that way we can even see the value of the private data member. Since we cannot directly access it, so we can use a function called get salary, which is public, to access it. Inside the main function, we are creating an object of the class employee. Object name dot set salary, and we are passing 50,000 over here. So automatically this 50,000 will be assigned to our private member salary. And then to print it, we are saying cout my obj, that is my object name, dot get salary. So since this method returns salary, so it will print that. Okay, let's see the output of this program. So look, over here, you're getting the salary 50,000 using the get salary method after using the set salary method. Okay, this is how once you have private data members and you want to access them, you can use get and set method to ensure that encapsulation is carried used properly. Okay, the example explained here: salary attribute is private, has restricted access. The public set salary method takes parameter s, assigns it to the salary attribute. Public get salary method returns the value of the private salary attribute. Inside the main, we create an object of the employee class. Use set salary method to set the value of the private attribute to 50,000. Then we call the get salary method on the object to return the value. So this is how encapsulation can be used. So is the usage of encapsulation clear to all of you? Let me know so we can move ahead now. Yes? Okay, great. So moving ahead. Today we are going to study about operator overloading. So if you all remember, I had taught you functions overloading, and that was one kind of polymorphism, right? Another kind of polymorphism that's called operator overloading. You can redefine or overload most of the built-in operators available in C++. Thus, a programmer can use operators with user-defined types as well. User-defined types meaning objects, etc. Okay? Now, to define an additional task to an operator, we must specify what it means in relation to the class to which the operator is applied. This is done with the help of a special function called operator function, which describes the task. Okay? The general form of an operator function is return type, class name, scope resolution operator. Instead of normal function names that you use, you will say operator. OP will be the operator, actual operator, the plus, minus, asterisk, anything. And then argument list, open brackets and function body, close brackets. Okay. So where the return type is the type of value returned by specific operation, and OP is the operator being overloaded. The OP is preceded by the keyword operator. Operator OP is the function name. So this is exactly how you have to do it. You cannot change the function name in any way while using operator overloading. You have to say operator, and OP will be whatever operator it is. And you have to say the return type is whatever this function as an operator task that will be carried out will return. Operator functions must be either member functions, that is non-static, or friend functions. A basic difference between them is that a friend function will have only one argument for unary operators. Unary operators can be anything, minus, minus, plus, plus, whatever, that work on a single operand, and two for binary operators, which is like plus, minus, etc. while a member function has no arguments for unary operators and one for binary operators. This is because the object used to invoke the member function is passed implicitly and therefore it is available for the member function. This is not the case with the friend function, because friend function needs all the things that you are going to be working on as it is not part of the class itself. So whereas the member function, you directly have access to everything in the class, so you just need to pass one operand extra if you're using binary operators, and if you are not using binary operators, then it is automatically accessing, so implicitly passed over. Arguments may be passed either by value or by reference. Now let's see a very simple operator overloading code. So if you remember, we had done this complex.cpp code, right? And we had written these functions add, subtract, etc., etc. And we were adding, subtracting, multiplying, dividing, and all that, right? So this was a normal function, right? Add, etc. Now let's see how we can do this using operator overloading. This is just one tiny example. So we have a header file using namespace std, class complex. In the private data members, we have real and imaginary as we did for this too. I'm giving you a comparative reference so that you'll understand the difference. Then complex int r is equal to 0, I is equal to 0, real is equal to r, imaginary equal to I. This is just a basic constructor. Automatic. Now we have complex operator plus, okay, complex, constant, and obj. So we are sending the address of the object of the complex class. Okay, complex rest, this is another object of the same class. So we have and obj, which is obj and rest. Okay, now rest dot real is equal to real plus obj dot real, and rest dot imaginary is equal to imaginary plus obj dot imaginary. Return rest. So since this plus is a binary operator, so it's going to work on two operands, right? So we have one which is our rest, which is implicitly passed, and we have another operand which is our object obj. So that way we are adding the real and the imaginary parts respectively to this rest object in this way, and we are returning rest. Okay, and then we are going to print it. So real and imaginary will be printed. Okay, int main complex c1 in brackets 10, 5, c2 2, 4. So these are my two objects. Complex c3 is equal to c1 plus c2. See, so this is how you're using the operator function directly. The plus will be used directly, and then c3 dot print. So let's see the output, what it prints. We get 12 plus I9, which is our addition of C1 and C2. So this is C3, this is a third object, and it is adding these two objects of the class complex using the operator overloading, where we are overloading the addition operator to make it add objects instead of numbers, the way it normally does. Okay. So this is a very simple example of operator overloading. If you go on the internet, you can Google more types. I'll send you this program just for reference, but it is very easy, so you don't really have to worry much about it. Okay, so I'll just tell you about overloadable and non-overloadable operators. The list of operators which can be overloaded, you can see this entire list. All of these can be used for overloading. So modulus, you can use it for probably remainders, or asterisk can be used for multiplying two objects, and you can say what that function is supposed to do. So this can be used for complex multiplication, etc. Anything. So all these operators can be overloaded. and scope resolution operator, dot asterisk, only dot, and ternary operator cannot be used for operator overloading. Okay, so is operator overloading clear to everybody? Just let me know. Yes? Perfect. Okay, so moving ahead. Now finally, the main thing that we usually know about object-oriented programming is inheritance, right? So we are finally there. We're going to learn about inheritance today, at least a little bit about it. Inheritance is the mechanism to provide the power of reusability or extendability, as we had heard when we were studying the basics, right? Inheritance is a process by which one object can acquire the properties of another object. Inheritance is a process by which new classes called derived classes are created from existing classes called base classes. It allows the creation of hierarchical classification. Hierarchical meaning, you know what hierarchy is, right? So you have grandparents, you have parents, you have children. That is hierarchy. So that way, inheritance provides that ability. Okay. Now types of inheritance, we had seen this before, but just as a revision. Then there's one base class and one derived class. This is called a single inheritance. When there are two base classes and one derived class, it is multiple inheritance. When we have one base class and more derived classes, it is hierarchical inheritance. When we have a base class, another sub-base class, and then finally a derived class, it is a multi-level inheritance. And when we have a base class, two derived classes, and another class which is taking functions and stuff from both of these derived classes, which is called as hybrid inheritance. Okay, so that's about the types of inheritance. Now, what exactly is this base class? A base class is a class which defines those qualities common to all objects to be derived from the base. Okay, so all those things which are in common will be in the base class. Base class represents most general description. So if you had a class called birds, okay, so birds would be the base class. Then there would be derived classes like birds who can fly, birds who can swim, birds who cannot do either, live on the ground, like the peacock, or not exactly a peacock, but maybe hens or whatever. That would be your derived classes, and then more derived classes. So maybe on what they eat, or stuff like that. So the base class will be birds, which is the most general description. So that way, base class represents most general description. A class that is inherited is referred to as the base class. So what is being inherited is our base class. Okay. Going ahead, we have derived classes. Classes that are derived from the base class are usually referred to as derived classes. A derived class includes all features of the generic base class and then adds qualities specific to the derived class. So this is pretty understandable, it takes all the general features that the base class is describing, so it doesn't waste a lot of time, energy, effort on that, and then it adds the features that are necessary for itself, and then those are inside the derived class. The class that does the inheriting is called as the derived class. The base class is inherited, derived class does the inheriting. Okay. Now syntax. The syntax for inheritance is class, derived class, colon, access specifier, base class. Example, class, derived class name, colon, public, and base class. Similarly, this public and C polygon, whatever. So this access specifier is required. Why? I'll show you. So members of the same class, members of the derived class, non-members. If it's public, members of the same class can access it. If it's protected, members of the same class can access it. If it's private, still members of the same class can access it. Members of the derived class can access the public and the private, protected, but not the private members. And non-members can access only the public but not the protected or private. So if you remember when I had taught you access specifier, I had said that the immediately derived class can access all the members which are protected. Whereas that's not true for non-members. Non-members cannot access the protected members. So that way security is ensured. So this entire image, please keep it in mind. I'll send it if you want so that you remember this. It's very generic. You can find it anywhere, but this is important when you're writing the access specifier. Okay, let's see that in more detail. So I have a class B, private, protected, public, non-inheritable, non-inheritable. So private is never inheritable. The protected. So I have class B1 public B, class B2 private B. So the protected data members will go into protected of this class B1. Public members will go into public. Whereas protected and public members both will go into private of D2 when I say private B. Finally, I have class X, public D1, protected D2. Okay. So this class is taking stuff from this class also and this class also, which in return are taking stuff from the main class. The hybrid inheritance maybe, right? So class X, public D1, public D2. Look what all it is inheriting in its private. It is inheriting nothing in its private. It is inheriting the protected members as its protected, public members as its public for class C1, and protected members and public members both are getting inherited as protected members for D2, because that's what we've written here. So this diagram makes it a bit more clear how the access specifiers work. I'll send this image too on the group if you need it. And going on to a little code of single inheritance, I'll show that to you. Oh, also I wanted to show you overloading conversion operators. So that I'll show you after I finish showing you the inheritance part. Please remind me. I had to show that to you. So since we did operator overloading, we can also overload the conversion operators. So I'll show that to you too. For now, let's focus on our inheritance. We have header files. We are writing it just normal syntax. Then we have a class vehicle. This is our base class. In the public, we have string brand is equal to Ford, and then we have a void honk, and it's the way horns are, toot toot, right? So just that's a public function. Both of these are public. Now we have a derived class, class cars, public vehicle. So this is single inheritance. This is just one derived class, one base class. This is inheriting stuff from this. Okay. And in the public, we have model Mustang. Int name, car, my car. So we are creating an object of car. My car dot honk, because since we are saying public vehicle, so automatically the public members will be inside its public, so we can access it. So my car dot honk. Cout, my car dot brand plus space and my car dot model. Since brand was also a public member, and since we have said public vehicle, so all the public members will be here as public members only. Therefore, we can access both brand and model inside our main, since it's all public. And let's see the output now of this single inheritance. See, when I'm calling mycar.honk, that function is getting executed, I'm getting the output. And also when I say mycar.brand and mycar.model in our cout statement, I get the brand and the model over here. So that's how single inheritance works. Now, I'm going to stop here with inheritance for today because I want you guys to try out a few programs. I don't want to overload a lot of things today itself because you've learned a lot, right? You learned about send functions, you learned about encapsulation, you learned operator overloading, and then finally this. So we will learn the rest of the inheritance part like multiple, multi-level, etc. and a lot more tomorrow. Today I'll stop here on the inheritance front and I'll show you about overloading conversion operators. right? So conversion operator, we can also write conversion operators that can be used to convert one type to another type. So hash include iostream using namespace std, class fraction, int num, numerator and denominator, and these are private. In the public we have fraction, in brackets int n in d, num is equal to n, din is equal to d. This is just a constructor. And then operator, float, constant, return float num by float denominator. So what this float is now going to be doing is it's going to be returning the float value of the numerator divided by the denominator or whatever. So you get that, right? So that's what this float is now going to do. So instead of returning direct the float of any value you pass, it's going to be returning the fractional value. Okay, so let's see. Int main fraction f, we are sending numerator and denominator to our constructor because it's a parameterized constructor. Float val is equal to f, so I'm calling the float operator loaded function. So float val is equal to f. I'm sending the object f to it because that's what it's accepting. Okay, and cout val, return 0. So let's see the output. Okay, so you got 0.4, which is a fractional value. So in this case, we've used the float converter to return the decimal value of whatever we are passing, the object of the fraction class. This is how we can do conversion operator overloading. This is just another type of operator overloading. Now, for today, I want you guys to practice single inheritance. So I want you to write a base class and a derived class. Practice that, just one though for today. And I want you to practice operator overloading in terms of anything. Either you can work more with the complex number. So since we've done addition over here, I'll be sending this program. Similarly, you can do for multiplication, division, etc. Or you can do operator overloading in any other class also. That is also up to you. So you can probably do string concatenation or whatever. Totally up to you. But I want you to practice both operator overloading and single inheritance for today. And this is it for today. So if there are no doubts, we will stop. Let me know if you have any doubts. If you don't have any doubts, let me know that too. So do you have any doubts? No doubts.